Okay, today we're going to talk about inflation. We focused on the fourth step in the investment decision, looking at the analysis that included the net present value, the internal rate of return, and then specifically we focused on the sensitivity analysis. The intent of that is, and I think I've stressed it before, is that the net present value by itself is probably not all that useful. But when you use it to start to get behind the scenes, what is the important information that you need, our assumptions on data, that helps us then get a better feel on whether an investment is going to be profitable or not. Up till now, we've assumed away inflation, and so today we're going to introduce this idea of how do you incorporate inflation into a capital budget. And before we do that, I want to give a short description of what we mean by inflation and talk about real and nominal cash flows that's associated with inflation, and also talk about real and nominal interest rates. The reading assignment, you're now in Chapter 11 on inflation risk and financial planning. Okay, first is a disclaimer. This is not what I'm going to present here a substitute for your macroeconomics. I'm giving you a vanilla-flavored nickel explanation of inflation, whereas that's a big topic and you can spend a whole semester looking at that and understanding what it means and how it affects the economy, what drives inflation. All I'm going to do is give you just a very brief definition and just enough information that we can hopefully use it in a capital budgeting decision. If we look at inflation, we can think of it as an increase in the general price level. The way to measure inflation is through indices, where you basically have a basket of goods and you watch what the overall total price of that basket of goods. If it goes up, the index goes up. And since that basket of goods stays constant, okay, if there's any increase in price, it's just an inflationary price. The consumer price index is one very common. In fact, you frequently hear that if somebody on the radio or the newspaper is talking about inflation. They frequently refer to the CPI, the Consumer Price Index. It can be argued that a better index is the Gross Domestic Product Deflator, which is frequently used in research, and there's some theoretically reasons to use one versus the other, and there's a number of other indices that can be used as well. You have the rate of inflation, which basically is the percentage rate of increase in these indices, and you seldom hear of the CPI is 1,560. What you hear normally is that inflation is 3% a year, or it's double digit, 12% a year. You hear it in relative to its change, its monthly change or its annual change. Also, let me indicate that inflation is an increase of all the prices or this basket of goods. But within that basket of goods, you may have oil prices going up and you may have house prices going down. You know, through that basket, you may have no increase in the price of that total basket of goods. You have to be careful. Inflation, if you're looking at inflation, it is not driven by relative price changes. When we talk about relative price changes, if you can look at oil, and oil may be going up, but inflation may be stable. And it's a little bothersome actually, because in the newspapers they actually say the inflation is higher because oil prices have gone up. Well, oil prices are going up because of the supply and the demand of oil, not because of inflation. There's a subtle difference in that you have to be careful of, because even the press, I think, make that mistake. You know, in my opinion, the reason that you have inflation, and there's a lot of others, this isn't a macro class, but if you have more dollars chasing the same fixed number of goods, you know, if you had $1 trillion in currency and you immediately printed another trillion, what do you think is going to happen to inflation? It's going to almost double, right? I mean, there's some other things going on there. This isn't a macro course, but there's some things going on there, but that's myopic view of inflation. That's how I view it. Now, you can also have deflation. If there's a contraction in the currency in the markets, you actually can have the overall price is going down. Now within that basket you can have prices going up and down, but overall you could actually have them go down. In fact, some argue that in the Great Depression in the United States, it was because of deflation. The government didn't have enough currency out there and created some real problems with depression of prices. Okay, the deflation is the decrease in the general price level. Okay, now let's start with that very simple explanation of inflation. Now let's start putting some vocabulary to it that we use in investments and capital budgets. This one word, nominal prices. Nominal prices, as we will use them in capital budgeting, is the prices as you observe them. If you pay $1 for an apple today, okay, that's a nominal price because you pay it. If in 10 years now you have to pay $2 for that apple, then the nominal price is $2 because that's what you observe, that's what you pay. You know, that's an easy way just to think about it. It's actually what you observe, it's what you count out. I frequently refer to it as the countable dollars. Okay, whatever you count out to buy something is your nominal price. On the other hand, the real price is the price with the general price level effect removed. It's prices that reflect today's purchasing power at a specified point in time. We'll try and keep that in this class pretty much at the present because we use the net present value. Everything is relative to today. And again, on our apple example, the nominal price for that apple in 2 years we said was $2 because it was countable. But in today's reference, it cost $1 for that apple, so in 10 years from now, the real price of that apple is still $1 because it's relative to today. Now, we're going to also refer to the nominal and real cash flows. And I'm using, the same concept of price and cash flows interchangeably, which is okay because if you keep the quantity constant, then, obviously if the price is nominal, then the cash flow is nominal. Now this becomes interesting because cash flows stated in real dollars over time can be converted to nominal dollars if we know the inflation. Conversely, if cash flows are stated in the nominal dollars over time, they can be converted to real dollars. To convert from nominal to real dollars and real to nominal dollars, we can use compounding and discounting factors that we used when we're doing the time value of money. And beware, because they look like they're the same, but their meanings are different. We'll try to sort that out. We can actually use our financial calculators and our 5 keys on our financial calculators to handle nominal and real to nominal, but the meaning is different. The real values do not mean present dollars. Okay, and you're going to have to come back to this as we introduce how we're actually going to convert from nominal to real. It's going to look like a present dollar, but it's not a present dollar. We're converting it to real in this context of nominal and real cash flows. Real values do not mean present dollars, but if today is our point of reference, present dollars are real and they're nominal, because today is our point of reference. There has not been a chance for there to be any inflationary effect on the prices because today is our point of reference. Now the notation. Now notice here that I'm using the F instead of V. We've used V in the past to represent a value associated with the cash flows of the present and future cash flows. I'm putting the notation of F here so it's very clear that even though our equations look very similar, not identical, but similar, they have a different meaning. So if we look at this F and we subscript it N, it's referenced as the nominal cash flow in year N. If we put a little star, superscript star on this F and subscript N, that refers to the real cash flow in year N. Now this I subscript F is the rate of inflation. Now I'm breaking the common tradition in nomenclature because normally a rate is referenced as a lowercase letter. In this case, I've broken the rules and I've put it as a uppercase I so that there's no confusion between that and the interest rate. Okay, that I, big I, subscript F, is a rate, but it's for the rate of inflation. In terms of the notation, okay, if we know the real cash flow and we want to convert that to a nominal cash flow, we are going to take the real cash flow in time period n and we are going to compound that at the rate of inflation for the n periods. Now if you look at that, that looks very similar to the future value of a single sum of money. If we wanted to find the future value of some present sum of money, we would compound it at the compound rate for n periods. Now what is the difference between those two equations? Okay, one is the rate of inflation. It's no longer the discount rate associated with the time value of money, it is the inflation rate. What's the other big difference? Okay, it has to do with the cash flow, but notice that in this particular case, we're already at time period n, where in this case, we're taking a present value to the future, whereas in the case where we're taking the real cash flow to the nominal cash flow, it's the same time period. Now mark that, and you're going to have to spend a little extra time thinking through that, because it's very easy to get confused, because as we go through this, we're going to be using the same keystrokes on our calculator, but the meaning is different. And if you don't get that right here, a flag, whenever you say you're going to be doing nominal rates or real rates, you've got to separate the meaning. We can also, if we know the nominal cash flow, we can calculate the real cash flow by taking the nominal cash flow and discounting it at the rate of inflation for the n periods. Again, this looks like finding the present value of a single sum of money, but again, it's not, because we're looking at a value or a cash flow in the same time period. And we're also discounting at the inflation rate instead of the discount rate. Now, let's see if we can just intuitively try and make some sense out of this. If you look at this now, maybe we can intuitively see where we're headed. Let's ask, what is the nominal price of an apple in 10 years if the real price is $1 and the inflation rate is 3%? You know, it's like asking if you can buy your truck today at $20,000 and inflation rate is 10%, how much is it going to cost you 1 year from now? It'd be $22,000, because it's inflating. So what I'm asking here, you already intuitively understand, you use it all the time. I'm just formally now showing you the arithmetic. Okay, so what is the nominal price of this apple in 10 years if it cost $1 today, but it's going to increase at the rate of inflation at 3% a year? Now again, we're assuming no relative price changes. Okay, we're just assuming the changes having to do with the increase in the overall price levels. So how do we calculate that? We know the real price, okay, which is $1, and we know the inflation rate, which is 3%, and we know that this is going to inflate for 10 years. So this is where, as pointed out, you can use your calculators. You can actually use your financial keys if you wanted, because you could put 10N, 3% I in your calculators, put a 1 in your future value, zero out your payment, and compute your future value, and it comes out to $1.34. And this is where I'm warning you, it's not a future value, it is a nominal value, because you're using the inflation rate, and it comes out to $1.34. We're pricing our basket of goods based on today's prices. Okay, so in 10 years from now, $1 is still going to be $1, because it's in today's pricing reference. Over time, because of inflation, the apple is going to cost you $1.34. But if you remove all that inflationary effect, okay, the relative price has stayed the same. It's still going to cost you $1 in today's dollars to buy that apple. How many apples can you buy today for $1? How many apples can you buy in 10 years for $1.34? Okay, again, we're holding the relative prices the same. We're just looking at inflationary increases. Let's turn this type of problem around and say, what is the real price of an apple in 5 years if the nominal price is $1.16 and the inflation rate is 3%? In other words, in 5 years from now, it costs $1.16 to buy the apple. If we're in an inflationary period and today is our point of reference, then what's the real price of that apple? And we calculate that by looking at the nominal price of that apple is $1.16. The inflation is 3%, and we're looking at a 5-year period of time, and so it comes out to be $1. The real price of an apple in 5 years, based on today's reference, is 1. We asked the similar questions. How many apples can you buy today for $1? Our point of reference is today. And then how many apples can you buy in 5 years for $1.16? Again, it's 1. You're probably asking, why do I have to go through this? Well, when we start talking about how to incorporate inflation into the problem, we're going to specifically refer to nominal cash flows or real cash flows. And when you look at an investment and you look out there and you say, well, 10 years from now I'm going to be getting off my cattle, I'm going to sell them at $70 a hundredweight, is that nominal or real? You're going to have to be able to answer that question. So what we're asking here now, although you probably see zero relevance to capital budgeting or even life, you'll see when you start looking at the future, you have to distinguish between whether you're looking at real or nominal. So it is relevant, and it's something you're going to put some mental capital into to sort this out. Maybe even this next segment, you'll probably see immediately more relevance, and it's looking at the real and nominal interest rates. If you look at a real interest rate, it accounts for the time value of money. And up till now, that's exactly the rate that we have used. We have assumed away inflation, so any rate that we have used, when we said the farmer requires a 10.5% required rate of return, he was expecting that his wealth would increase by 10.5%. However, in an inflationary environment, we have to look at the nominal interest rate, and it's almost always the nominal interest rate that is quoted. If the bank says they'll lend you money today on a 30-year fix for 7%, that is nominal, not real. It is nominal because it not only includes the time value of money for that bank, but it also includes a portion to account for the inflation, because the bank knows in an inflationary environment that $1,000 mortgage payment today is a lot more than the $1,000 mortgage payment that you're going to make 30 years from now. Because in 30 years from now, that $1,000 is only going to buy about a third of what it does today. They recognize that. Thus, they include an inflationary portion of the rate. The mathematics of this now is where R represents the nominal rate, the R star represents the real rate. You see a pattern here. In this class, I will put a star, superscript, over things that I reference as real. And if it doesn't have a star, it'll be referenced as nominal. So the nominal interest rate is the real rate, the rate of increase of wealth, and the inflationary rate, that just is the increase of prices without changing any of your purchasing power, plus their interaction terms. Now, if you do the arithmetic on this, you can find that that can be rewritten as 1 plus R, 1 plus the nominal rate, is equal to 1 plus the real rate times 1 plus the inflation rate. Now, if we divide both sides by 1 plus the inflation rate, then we have 1 plus the real rate is equal to 1 plus the nominal rate all over 1 plus the inflation rate. And if we subtract 1 out, we now have a definition for the real rate. If you know the nominal rate, and that's what's usually quoted, and you hear that inflation is 3% or 4%, then you can calculate what the real rate is. Now, it turns out that for a quick and dirty read on what the real rate is, the real rate is approximately the nominal rate minus the inflation rate. And that's a very useful thing for you to think about. Now, in this class, if I ask the real rate, I'll expect you to go to use the more elegant equation, 1 plus R over 1 plus the inflation rate minus 1. But it's also important to recognize the quick and dirty rate for the real rate. For example, if right now I hear that inflation is 4%, and I can purchase a bond that has a yield at 7%, what's my real return on that bond? If the nominal rate on that bond is 7% and inflation is at 4%, the rate of inflation is 4%, what is the real rate? 3%, which means my increase in my wealth is 3%, not 7%. It's only increasing at 3%. Now, where I've just heard that inflation, and this is probably just a temporary thing, historically in the last few years it's been 3%, but I heard on the radio it was 4%. It jumped to that. If you have your money in the bank and you're earning 1%, what's your real rate approximately? You are losing 3%. In your purchasing power, 10 years from now, when you take that money out of your bank, you're going to actually find that your purchasing power is decreased by 3% a year. Hopefully that's a wake-up call. But right now, where you can take a CD out for a year at 3%, and if inflation's at 4%, what's happening? You're basically paying the bank 1% of your wealth to hold your money. If you are in an inflationary environment and you had your money in your bank at 10%, but inflation is 10% over a 10-year period of time, how has your wealth changed? Absolutely nothing. You've conserved your wealth, but you have made nothing. If it wasn't in the bank, then you'd be losing 10% of your wealth. However, you may also be looking for the investments that are going to return more than that, so you're getting a real rate of return. You know, this is something that's easy to get your arms around that's important. Okay, this next slide is just a formally looking at what we just covered. The yield or interest rate on a bond is 6%. If inflation is expected to be 3%, then let's calculate the real interest rate on the bond, and we plug it into this formula. And yes, I do expect you to know this formula. The 1 plus the 0.06, because 6% is the nominal rate. Out there in the real world, whether it's a mortgage rate or the interest on your car loan or a bond, it's always stated in nominal dollars or nominal rates, unless they specifically prefix it with real. Otherwise, if you hear 6% out there, it's nominal. So if the yield on the bond is 6%, it's 1 plus 0.06 divided by 1 plus the inflation rate, which we said was 3%. We do the arithmetic, and we see that it comes out to 2.91%. On the other hand, if we would have used the quick and dirty method, we would have said the real rate was approximately what? 3%. But the true rate, as we see here, is 2.91% that accounts for their interaction. So in this class, I expect you to be precise. You have your calculators, you got the formula,